So today I'm going to continue the routing. So far, if I go back to the outline, so we talked about the concept of layering, and we talked about how we measured performance, and we talked about why the 9-bit is prone to error, and we checked how to overcome it by adding a redundancy. Then we talked about reliable retransmission. When do we have to retransmit it? And what if it is multiple access? Multiple guys try to share the one media. Then we talked about when it is specialized to the wireless network. And we talked about the 802.11 wireless LAN. Then we talked about internetworking, so network to network, right? Then we talked about the routing, so how my packets are traveled from one point to the other point. Okay, so today we may continue the routing. Slideshow from the start. So routing has multiple types of routing. So before we do, I have to advertise myself. So we call that one as broadcasting. Hey, here I am. Then everybody, your adjacent or in its range, notice that you are there. And when you say something, you may provide some information. Hey, this is me, and this is my performance. And by talking to them, then they can choose the metric, something like a latency, something like the throughput, all kind of things. So it always starts from broadcasting. Broadcasting is tell everybody, okay? So I'm introduce myself, something like this. So broadcasting communication, all nodes of the network must receive the same message, like something like a TV and radio are default broadcast operation. Whenever they talk to, everybody just listen to it, okay? Unicasting meaning I'm talking to one guy, then everybody else is not able to listen. Okay, maybe you can overhear it by using some kind of the hacking method, but basically unicasting talk to one. All the other guys assume they are not listening. So source needs to transmit message n times to talk to n guys, right? So precisely, I need to talk to n-1 time. Let's say I have n nodes in my network, except me is n-1. So source needs to transmit messages n-1 time. Okay, so address of all recipient must be known. Therefore, I can talk to directly, 1-to-1. So total of n-1 messages must traverse the world, traverse the network. So all neighbors are not able to reachable by me. Okay, so it should be relayed in between. Okay, and the flooding. Flooding is inefficient use of bandwidth, meaning I'm telling everybody. There is no destination. So everybody, whoever listened to it and has to relay if the message is intended to relay. If not, they can discard it. Okay, so flooding is inefficient use of bandwidth because I'm using everything. Node receive the same message multiple times. Of course, everybody talking about same messages. Does not scale with the network size of n. If the size of the network is big enough, the flooding does not work because everybody's just talking, right? So there should be some mechanism, okay? If I receive the message multiple times from the same sources, I have to discard it. Then I can reduce the flooding, okay? And a spanning tree routing, I assume you know about what is a spanning tree, right? The MST, minimum spanning tree, and prims and cross-causal spanning tree, right? You learn in the previous courses. So spanning tree routing is build a minimum spanning tree from a source to all nodes. Therefore, I know how to travel from me to them, me to them, me to that guy, me to that guy. Okay. Source needs to send message only once. Therefore, messages are hopping through. Then it can reach the destination to everybody. So let's say I have multiple nodes. By building MST, it may look like this. There's from source to all destination. Okay, so source needs to send messages only once. To reach D1 message to this guy and go up, then all once, right? Then in the middle guys, they may relay or no. Okay, so source needs to send So message is relayed total time of n-1 time. In the worst case, if the spanning tree look like this, total relay time is network size n, 1, 2, 3, 4, 4 times. Network size 5 is 4 times, n-1, because they need to disclose me. All right, so how to build a spanning tree? There's many mechanisms. You may use the prims and you may use a cross-call. Let's start with the cross-call. Cross-call algorithm is greedy approach. So add edge with the smallest weight, then connect one or two new nodes together. So repeat until all nodes are added. So saying I'm sending from me, so my network is now initialized. Then I'm choosing 4 or 9. I'm choosing 4. Okay, so this is my network. So from here, my network is candidated 319. From there, I choose 1. So my network is CBE. From here, I have choice 1, 1, 9, 2, 3. But 9 is not necessary. So 1, so I can choose 1. So my network is CBEA. From here, I may have connection to 621. So I choose this guy. And my network CBEAD. And from here, I have 2 candidates, 2 and 6. And by choosing 2, then I visit all my nodes. I construct minimum spanning tree. So therefore, I know how to reach all my guys from me to everybody with the minimum cost. Okay, cross-call is greedy algorithm. You keep repeating until all nodes are added. And basically, broadcasting concept is same as the flooding. So all edges have the same weight in the basic way, in the default. So any spanning tree is a minimum spanning tree. A spanning tree is the same regardless of source of the messages. Okay. So reverse fed forwarding. Let's say this guy is my source. If the packet arrives from preferred router, then forward, otherwise discarded. Okay, preferred route means route on the reverse shortest path to the source. So remember, I have this shortest path. Let's say shortest path look like this, a little different from the previous. If the packets are coming via this link, I can discard it. If the connection is coming by this way, I can discard. If the connection is coming by this way, I can discard. Meaning, this is not preferred route. Okay, so reverse path forwarding, because I know the MST, minimum spanning tree, and I know which path is preferable to me. Okay, therefore, preferred router on the reverse shortest path to the source. If the packets arrive from a preferred route, I do forwarding, I do relay. Otherwise, discarding. Very simple way. So therefore, I can prevent the overwhelmed flooding, right? And broadcasting in wireless multi-hub networks. So now it is a little complex. Now we talk about wireless networking. What's the difference between wireless network and wired network? So if I So difference between wired wireless. So how much do you use in proportionally, wired or wireless? So you're using most of the phone and you're using notebook without RJ45 without Ethernet cable, then this is overwhelming these days. Long time ago, wired was overwhelming because technology of the wireless is not mature at that time. Now we believe it is wired enough and mature enough. So wireless is so commonly used. So what's the difference between wired and wireless? Let's say I have a multiple network. If I'm setting a new computer, new laptop, what do? I attach to existing network, then I can start connected to the internet. Okay, if I'm moving in here, I attach to a new network, setting a new IP and connect to the internet. Okay, how about wireless? Wireless is something like phone. You are connected to one AP and you are moving to and the other AP. You have to attach to the other AP. Now you roam around. We call it roaming. Roam around. Then you need to attach to a new AP. And also, wired network is not. There is no concept of the range. If you're connected, it's a connected. But in the wireless, oh, I have a communication range. Let's say it is 10 meter in Wi-Fi. If I'm using LTE, my range is 1.6 kilometer. If I'm using a LoRa or WiMAX or something else, then the range is about 1 kilometer, about 1 to 2 kilometers. So the biggest difference between wired and wireless, I have a communication range. So communication range meaning I have to maintain the communication range from the existing network to myself. Okay, so remember this, go back to the point. So broadcasting in wireless network. So now my broadcasting can reachable, and that broadcasting determined by, not by adjacent list, but by my power, transmission power, right? So we have to take into account the energy, meaning I can increase the power, then I can say louder, then I'm using more energies. So we talked about, when we talk about your phone, what do you check first? My battery. My battery is 70%. If I talk loud, I'm drain more energies. If I talk this small, then I can last longer. Okay. So in the wireless, we have to take into energy. So broadcasting advantage, if I talk to SB directly, I have to speak loud enough. What if I'm talk to the whisper to A, then A whisper B? Then communication range is small, meaning I'm spending less energy. So broadcast A, then A will forward to B. Whispering 2 times is better than shouting. So if it is available, okay, this called broadcast BIP, broadcast increment power. So initially source is there. So whenever I want to add my network, like we did the MST, I'm keep increment the power level. Hey, hello there. If there's nobody, then I up a little volume up. Hey, hello there. Nobody. Then I start to increase. Hey, hello there. Then hey, I'm here. Responded. Oh, you are there. Okay. I'm thinking about whispering network to save my battery. Then they made a connection. Now network is built up this way. Then they start to whisper again. Hey, hello there. And hey, hello there. Whoever finds first included my network and whisper network. Okay, that is broadcasting increment power. From the smallest power I can transmit, then the stronger power. So power level, if I speak louder, it is exponentially increased. So smaller power meaning more efficient in terms of the energy saving. So initially your network is S starting from this guy. So minimally increase the power. Okay, that start to increase the power of whispering and a little louder to find a new node, and repeat until all nodes added to your network. And greedy algorithm leads to the non-optimal solution, meaning I have to keep repeating. There is no the solution because the configuration of topology keep changing. Okay, so what if in this case, this only happens in the wireless network. So what if your host is keep moving, your network is keep moving? Say, okay, let's say this is a Korea. I'm from Incheon to Busan. I'm taking KTX, and I want to stream Netflix. Netflix, is it Flix or okay? Let's say I'm streaming YouTube. Okay, how does it work? So I'm using my phone. Let's say my iPhone. So I started from Songdo. It's connected the base station, positioned. So base station. So base station position every 2 kilometers. All of the country. Okay. So I'm initially connected to this guy. Then basically I'm moving through. Basically I'm moving through the KTXS line and connected to this guy, then connected to this guy, and this guy, and this guy, and this guy, this guy, this guy, initially. So it may up to about, since this range is 2 kilometers, I may deal with the 200 base stations, about 200 base stations. Then how about YouTube in California can stream to me? This is complex, right? How does it work? So I'm keep changing base station, then how the YouTube keeps streaming to my mobile device. How does it work? So let's think about this for 2 minutes. Then I'm gonna pick the guy. Okay. All right. So Ulbek, what's your idea?
I don't know, like it seems like complex question.
Just guess, and any solution if you have.
Okay, just I'm thinking when you like change station, before changing station, you already have like some download some part of the, let's say you download like 5 seconds or 10 seconds, and change station, it will not in. Oh, is it professional streaming?
It is. Let's say that. Let's say it is a streaming. So in the streaming, the delay tolerance is 250 microseconds. So if it is a more than a 250 microsecond, you feel the jitter. So let's say in an actual with the buffer mechanism, let's say if it is longer than 1 second, let's say it is longer than 2 second disconnection, you feel the disconnected. Okay. So the human perception, if it is longer than 250 microsecond, people feel it is disconnected. But because we have a buffering mechanism, then if it is a longer than 2 second disconnection, then people can notice, oh, it is disconnected. Okay, let's talk about longer than a 2 second. Any idea?
No.
Okay. Taejun?
So what I think is that we should probably like make a, like, I don't know how to say it, like maybe a node that sort of just calculates like where the user is currently. So basically the only thing the node does is that it calculates the sort of the strength of from like how much information each base station can provide to the user.
Mhm.
So based on that, that node automatically connects it to the user
Stronger
like
one?
in real time.
Okay, so you mean the node can calculate who is a faster, who is a stronger, and then keep handshake.
Yeah,
Attached
exactly.
to the stronger one, attach the stronger one. Okay, good point. Jaewon? No, is Jaewon here? So he's here, but not responding. Hojin?
Oh, I'm not sure.
Okay. So you missed the last class, right? Hojin?
Kind of. My machine wasn't working.
Okay. All right. So you may follow with the, you may catch up with the YouTube link. I hope so. And okay, who else? Who has an idea? How can you solve this? Nobody? So this concept is called handover. There is two concepts. 1 second.
Can I take a guess, Professor?
Sure.
So I don't know whether the LTE system is similar to Wi-Fi, but
Okay.
like so there will be an overlap between two stations, right? Like there are like distance between one station and the another that will be like similar, so that a mobile host can connect either one of them. And then if the mobile host is closer to a station than the other, it will try to connect to the other one and then notify the previous one that it's trying to move over to that station, and then the previous station would send information to the other station that's being connected. So it will kind of hand over the information to the other station as long as the mobile host is connected to both stations and disconnects with the previous one and then passovers to another one, something like that.
All right.
Like between APs, maybe? I don't know.
Okay. All right. Very good. So how does it work? It looks very complicated, right? So why is my pen is not working? Say I have a CDN of the YouTube. Let's say I'm streaming from California. So YouTube is application. So application is basically point to point. So I'm streaming to my mobile. So in the middle, there is a SKT. Different column, SKT, and provide me, right? So whenever I'm asking from my iPhone, it go to my SKT network and accessing my YouTube contents, and YouTube content is hopping SKT and coming in here. So you know that in the SKT is not only one. So SKT has multiple base station. So on top of building, so I can see the base station on top of SUNY Credit building, on top of the IGC dormitory building, the huge radio. That's all LTE radio. It look like this. Okay. So conceptually, I am connected by one of the base station and in here. So when I initiate the network streaming from the YouTube, this is called my home base station. Okay, so let's say I've traveled to the Gwangmyeong for my new service. Okay, meaning, oh, new base station, just notice that there is a new attach. And there's detach from the previous. Then what happened to the network? So packets are keep streaming to the homes. Okay, there's nobody. Then whenever they notice that, oh, there is new attached to me, then this guy talk to the SKT. Whoever goes to this guy should coming to me. Okay, then whoever network goes in this way, come back to here, goes there. Okay, so it looked like basically telling this guy to base station, hey, this guy come to my range, and whoever you have, whatever you have, please forward to me. Okay, I'm leaving here. I'm detached. Then notice my SKT. Then SKT keep forwarding me. But remember, there is a YouTube keep streaming to my base state, the home base. Okay, so packet now look like go to my home base station. So whoever goes to home base station, which is my base station of the AP, then mobile ID 01011112222. Hey, whatever you are receiving this pattern should go to this guy. Okay, then SKT in the middle, they are smarter. So whoever goes to home base station, it happens handover. Then keep going. So let's say I move to the Busan finally. Then this detach happened over 200 times. So YouTube may think I'm keep transmitting to this guy. Okay, then SKT handles rest of it. Therefore, system is a simpler. If you have to configure the YouTube, also notice, oh, there's a destination change. The YouTube engineer cannot handle everything, right? Therefore, SKT handles that handover. Okay, that is an advantage of the layering concept. Because we have a layering concept, it is a possible. So new network attached to the new network. Oh, notice that home address. We don't notice these in the middle. Home address, update this information. Then SKT handles to the next guy. Okay, this is what happened, and this is called handover. This topic was hot before the 3G was a popular. Long time ago, 2G, we don't have those concepts. There was no data communication, only the voice. So whenever you change the base station, there's disconnect and reconnect, disconnect and reconnect. That is a 2G network. From the 3G, it is now the data. If the 1 bit miss, is a critical. Unlike the voice. Voice, just disconnect and I can say it again. In the data, I have to make sure integrity of the packet. Then from the 3G, this handover is critical. And about 2007 to 2010, this topic was popular. Then it is all solved by the handover concept of the home agent and attach agent. Okay, any question? No? Okay, move on to next slide. So routing for mobile, host moving from one network to another. So if IP change, certain service may not work, meaning something like YouTube. I'm streaming to that IP, okay? So home agent, so your YouTube, just keep telling home agent, the first attached network. So in the middle, there is the SKT, then whoever comes in here with the bypassing to the foreign network. This is a very basic concept, okay? So let me show you how the mobile host routing, and this is how the packets are traveled. Let's say I was here, I was taking my jet and moving in here, and I'm streamed. So my hub is first here and here. Let's say not the jet is not available. Let's say, what is this called? I'm fast enough. Let's say I'm a Superman. I'm connected in here and connected in here. Then I still want to stream. So while you're flying Even for the Superman, while you're flying, you want to watch YouTube. Okay. So packet is sent to the mobile home address. Then you move to this point, okay, in the next time, and packet is tunneled to the foreign agent. It is possible based on this concept. So whoever comes in here, then the base station in here, notice that, okay, you know what, you don't need to go all the way from to there and come back because I am attached to new. Then this one, let your SKT knows, and this one streaming to that point. So subsequent packets are tunneled to the foreign agent. So home agent is initial base station, you are attached. The foreign agent, they keep following. Okay, all right, so now move on to the next next thing that we call the routing and AODB, ad hoc network. What is ad hoc network? So we have two mechanisms. One is infrastructure, the other is ad hoc. Infrastructure is you have AP and you have a multiple notebook. They call the infrastructure. Ad hoc network, you have notebook and notebook and notebook and notebook. They make a mesh network. They make any kind of network. And one of them is connected to internet. Then they can provide the internet to its vicinity. Okay. So AODB concept is popular in the sensor network. Sensor net meaning you have a big farm, you are not able to provide the whole base station, whole AP for everybody. Rather than doing this, the network is, the node itself are connected to each other. So whoever they have the internet, then they can provide to everybody. Okay. So a long time ago, we didn't know who would win the infrastructure of the ad hoc network. So in 2005 to 2012, we still fought at that time. Now the ad hoc network is almost gone. We are using the almost only infrastructure, unless you are in the specialties. Okay. So the AODB, AODB is a very popular, and there is a competitor AODB and DSR. And let's see, let me show you that. AODB routing protocol. AODB Wikipedia. So AODB routing is a routing protocol for mobile ad hoc networks and developed by U of California, USB, and Samir Das. Samir Das is faculty in Stony Brook. So we are part of it, okay? So there is a DSR. DSR protocol, dynamic source routing. DSR is, what is this? No name on it. I can't remember the name, but I met both of them. DSR, AODB, inventor of the DSR. Dynamic source protocol. DSR, who did this? RFC. David Johnson, I'm not sure. Oh, yeah, David Johnson, D. Johnson. So he received, I think he received the Turing Award. David Johnson. Sorry. Microsoft. David Johnson. No, none of them. No, not this guy. Well, anyway, I think TSR, the David Jones from Microsoft received it. I believe he received the Turing Award. I'm sorry for that. But yeah, in my memory, I think he received the Turing Award. You know the award, the Turing, right? There is a Nobel Prize, and Nobel Prize for commonly known, and Turing Award in math and computer science, and Field Award in the mathematics. So Turing Award by the ACM, and Nobel Prize and Fields Award. That is two. There's a three most distinguished award that human can receive. I think he is one of the recipients. He invented many things, not just a DSR. Okay, so we are talking about the noticed one. Okay, so start with the AODB. So long time ago, infrastructure and AODB was that they were equal to equal. So we didn't know who would win. So in the industry's choice is the infra. So that is why we are using the AP and connected to the AP. Whenever we move to, we don't provide my neighbor's network, but I'm only rely on my AP. Okay, when we're talking on Wi-Fi. So a long time ago, we didn't know. So AODB was so popular, it is cited more than 30,000 times in the paper, in one of the most famous paper in the computer science. So AODB basically basic steps. Source node floods the RREP. We need to understand what is flooding. Oh, it tells everybody. RREP is route request. Oh, tell me how do I get to you? Tell me how do I get to you? That's RREQ message. Okay. Hey, how can I reach you? Okay. That's the first step. And every receiving host keeps the reverse path to where the package came from. Hey, A is advertising to everybody. Whoever receives the B, okay, that I'm receiving from A and sending B, adding B. Okay, I'm receiving from A, adding B. Hey, so A told me he want to know everybody. Then I can shout again. Okay, then B shout. This link receive A and B, and C receives. Okay, then C shout, meaning A, B, C. That way. Therefore, so A shout everybody, whoever is range receives the A. So in this case, B and D. Okay, B and D receives A's flooding, then B start to shouting in its vicinity. So D can ignore the B's message because they are delivering same messages. Then this path is constructed. D is also shout this path and this path because D is shouting in this one. Okay. Then reverse link, reverse link. Now C, G, F is shouting. Okay. Then there is reverse path. So what did I do? I discover everybody in my network, and I know how to get there by this reverse link. By this link, I can reach to A, can reach to B, A can reach to C, A can reach to E, A to D, A to DF, A to H, A to G, A to I. Okay. So once the message reaches the destination, it replies RREP. Okay. If I do it again, say my destination I only, then hey, how can I get to I? B is receiving, oh, I don't know. Maybe I ask the others, hey, how can I reach the I? This pair keeps sending each other. After they construct all this link, we call reverse link, then I, oh, hey, A, what's going on? Then there's reverse link. In the reverse link, I don't need to shout. I only do unicast, okay? Once the message reaches the destination, it replies RREP, route reply. RREP is forward the unicast path back to the source. So here was flooding and unicast. Here was the broadcasting telling everybody, hey, how can I reach I? Then I, okay, here I am, and I can talk to Salon to the back, okay, to talk to G. Hey, tell A I'm here, okay. Oh, G is telling, I told me he can reach by me, okay. Then reverse link, they can communicate without hinder the others. This is basic AODB concept, and this is RREQ message. This is RREP message. RREQ, RREP. So RREQ message. Whenever I do broadcast, there's a source address and request ID. So I have to know. I have to prevent the looping through and multiple retransmission. So I set request ID. Whoever I receive the request ID multiple times, I'm taking the newest one. So our destination request ID prevents that, and destination address. There's destination. I want to talk to him, and source sequence. That sequence number provide the freshness of the RREQ. Unless if I'm receiving multiple messages for the same thing, I'm only take the fresh one only, okay? And destination sequence and hop count. Then I can prevent the loop. Destination sequence number, freshness from route to destination. Source sequence number is freshness of the RREQ. Okay, so freshness is important because I'm broadcasting to everybody. So if someone talk for the same thing, then I'm choosing the fresh one. Okay, whenever I reply, okay, source destination. Of course, I'm doing point to point, and there's a destination sequence. Okay, so this is the reply for source sequence and destination sequence. Source sequence to destination sequence, meaning I have to. Even if there is a multiple response, then I have to choose the most fresh one. Then there is hop count. Therefore, I can prevent the looping and lifetime. If there is a so delayed, then I have to have mechanism to kill it. Okay. So this is the message format of the RREQ and RREP. And how does the route is maintained? So active neighbors. So neighbors are that maintain active path. So active path, let's say these routing table from G. So there was a G, if you remember, there was a G in the middle. Was it like this? 1, 2, 3, 4. Okay. So let's say G's connection is down. How does it happen? Okay. Let's say before G is down, look at D's routing table. D's routing table A, okay, reachable by me. Reachable by, so if I'm telling reachable by A, the hop count is 1. So active neighbors on the reverse one, so they are actively maintained. Okay, so active neighbor can be FG B, but a B is not actively doing it, then I can count an F and G. So destination of the B, I can reach directly. Then hop count is 1, and next hop is itself. C, by a B, I can connect it to the 2 hops. E was a buyer G is a 2 hops. F is directly with the 1 hops. G itself, G is 1 hop directly. H was 2 hops via F. I is 2 hop via G. Okay. In the middle of the communication, let's say this node is down by a replacing or a shut it down. What should I do? So it goes down without notice. This is commonly happen in AODB. Why? Because I'm talking about mesh network. I'm talking about ad hoc. In the infrastructure, it is very less because your connection is maintained by network administration. But ad hoc network, someone goes up and goes down and goes up and goes down frequently because you're talking about sensor network. They can be replaced without notice. Okay, meaning if the things that goes down without notice, then it's neighbors who has maintaining it, has responsibility to be connected back to the network, right? Therefore, in the middle guy, I think it is D. D has to maintain. Okay, this goes down. Have to notice everybody. A, B, F, right? This node is C. This node is H. Okay, notice. G has no ability to notice everybody, but it is the vicinity, direct connection should notify everybody. Then network is keep connected. Okay, then this guy, okay, whoever wants to connect to this guy have to reroute. Whoever connects to this guy, because I'm maintaining active list of my G. So whoever connected, and you should reroute. Then except G, I'm still maintaining my network. Okay. So move on to the. So we talked about the AODB until here. It is AODB. Oh, AODB works in this way. Let's talk about DSR. DSR works a slightly different one, very similar. So source determines the sequence of node that packet must follow based on the cached information and route discovery phase. Oh, this is almost same thing. If the something is I know already, meaning that is cached information. If I know the status of the network by the process of the route discovery, then I know that. The advantage of DSR, there's no periodic route updates, as in the DB, so something in AODB. AODB is acronym for ad hoc distance vector routing. The distance vector is DB. So there's no periodic route updates in DB. In AODB, I'm periodically asking RREQ. Hey, I'm here. Then by doing this, there's no this hello messages. Therefore, that saves the energy resources. And no need for bidirectional link as in AODB. AODB always require, hey, if I'm telling them, then there is reverse link. They call the bidirectional. And DSR's advantages can quickly adapt to the change. Something is changed, I can quickly adapt in DSR. Okay, because I'm using cached information and route discovery phase. We're going to talk about this. So this advantage of DSR is route is specified on a packet header that can grow fairly long. I can keep adding as I propagate. Meaning if I do relay, I'm using my previous information, I'm adding the new information that the new information is keep growing as we have a longer and longer. And use flooding for routing discovery as well. That's the same thing with the AODB. So route discovery in DSR, sender broadcast route request RREQ packet similar to AODB. Each intermediate node, if the source IP is the same, discard it, meaning I'm receiving multiple times. If the address of intermediate node is already in the route record, I can discard it, meaning I'm looping through. So node is target. If the node is target, then I can send RREQ, right? Else, append node is addressed to the route record and rebroadcast. Okay, this is how it works. So A wants to find the destination for everybody. Let's say it is destination is I. A is broadcasting. So this first packet is only A. So in the middle, B is receiving. Okay, I need to broadcast again. Then I'm appending my information. Then broadcast. D is also receiving A's messages and appending D and talk to them. While it was talk to them, so B is receiving A and B, but D already received the A's messages, then I can discard it. Okay, the epidemic method. So C broadcast ABC, ABC, right? Then E is sending ABCE. But you know what? I have a faster link because D is a broadcasting. Then A and D, okay. G is receiving multiple times, A, D, A, B, C, E. And F is also talk A, D, F. And A, D, F, G, maybe talk to them. So G is choosing this guy. Also, ADG is coming this way. Then they have the earlier one. Then they choose ADF, ADFG, or this guy received ADG from here. Then everybody received the messages, and there is the discovery path. Okay, whoever receives destination, they can send RREP in the reverse path. Okay, so this is the mechanism, basic mechanism of the DSR. So what's the difference between DSR and AODB? So remember, I'm keep appending my information. In AODB, just epidemic way, there is no keep appending. So whoever receives it, just a simpler mechanism. In AODB, it's much simpler, right? And there is a more mechanism we call the joke. So we talked about most famous routing algorithm in the ad hoc network, something like the sensor network. One is the AODB, the other is DSR. They are two famous. But if my memory is correct, whoever invented the DSR received the Turing Award, and AODB's inventor is one of the inventor is the Stony Brook. So our school. Okay, let's talk about
a question.
Sure.
For DSR, does it discard the packets that have longer packet heads, or does it discard it by like how which one was connected faster?
Okay, so let's talk about this. Okay, it has a mechanism based on the situation. I'm receiving first, then if I forward it, that is chosen. Okay, I'm about to transmit, but I have two choices. I'm receiving from two sources. Then I'm choosing the shorter one. So based on the status. So priority is whoever comes first. If I'm receiving multiple things, I'm choosing the shortest one.
Then let's say like for G and H, between G and H, say ABDG received first, then would it discard the other one? Yeah.
So AD and ABCE and ABDG. So that's this pattern. So it should be ADFH, right? So I have four candidates. Whoever comes first is the choice. Basically, if I travel 2 hops or 4 hops, 2 hops comes first.
Oh, okay. What if it says 4 hops came
4
first?
hops comes first, and then 4 hops goes away. This means there's a huge latency in the 2 hops.
I see. Okay, thank you.
So yeah, this works in a very fast way. So if I can share okay, let me share how does it work. There's chat, David. So ad hoc is wireless. Freshness means whoever comes the last, who has the latest information. Okay.
Yeah, I got it. Yeah, thank you.
All right. So if I go back there, go to the YouTube. So when I was undergrad student, we used to use NS2. So this is how it works. So time domain, animation. So it shows the RREQ. So do you see the animation? So you send RREQ periodically. So I think it looked like this. So I have a sensor network. So this is the this is how the RREQ message look like. Keep broadcasting. Okay. In this case, freshness is the key. Okay. Which one is a better path? And even your RREQ and RREP, this mechanism works in that way. Okay. And this is common in the sensor network. Okay. Go back to slide. Okay. David, thank you. Good point. Okay. So there's a new mechanism. Oh, you know what? AODV and DSR are sending too many broadcasting, and there is reverse path. I think it is too complex. Okay. Then people think about, oh, okay, make less the broadcast messages. And there's a geographic routing. Geographic routing is route based on the geographic location, and send packet to its neighbor closest to destination based on geographic coordinate. No need for route discovery or the routing table. Then, but I have to have huge assumption, meaning I have to know XY coordinates. I have to know XY coordinate. Then, if I want to connect it to this guy, hey, I am XY is, let's say it is 1 to 10. I want to reach 10 to 2 guy, XY location, right? Then, oh, okay, roughly I get closer by this one. Based on my adjacent list, you must be the closest one, okay? Then you say, oh, you are reaching 10 to 2. Then among my adjacent, I should talk to you. Oh, he's my neighbor, then I can connect it. That's a huge assumption there. I have to know XY coordinate. In real world, it's like GPS. I have to know the coordinate. Okay. So geographic routing is very efficient because I don't need to waste the RREQ message. I don't need to use the RREP message, but I have to know geographic coordinates. Okay. And geographic routing may stuck. Why? So, oh, I want to reach T, okay? So let's say I am 2.5. I want to reach 12.9, okay? 2.9, okay? Among adjacent, I should go to this way. Among adjacent, I should go to this way. Among adjacent, I should go to this way. You know what? I'm none of them. Let's say there is no link between. What should I do? So geographic routing may stuck because I'm relying on XY location and I'm not maintaining routing path. So node is close to the path, yet there is no transmission to destination, meaning if there's no link, I just assume that because I'm not maintaining routing table to save the RREQ message, RREP messages. This may happen. Okay, then how can I overcome? So you understand the problem, right? So AODB and DSR, they are keep maintaining their routing table by sending RREQ and RREP. And there are two very similar but different mechanisms. But you know what? Sending that RREQ messages are wasting, and there's messages so frequent, and we don't want that happen. And there is a geographical routing based on geographic routing, but they have to know their coordinate XY location. But by just sending it, they may stuck in cases like this because this may not have a connection to them. Okay, how can you solve this? Okay, let's talk about this for. Let's think about this for 1 minute. Good.
I'm not sure.
So you
Sorry.
understand the question?
I might not.
Okay, Minhang?
I think there should be an what's it called? Like a set up boundary among geographical region that if it there should be some kind of set point that if it goes beyond this line, it has like the process has to be aborted because it goes beyond the what's it it doesn't get the efficiency goes beyond that point if it were to go to the certain destination.
So you mean this guy noticed that, okay, I'm not reachable. Then this guy is prevent go to this way and steer right or top or bottom. So it is naturally goes to steer to the top, and this guy to keep reaching to this way. Is that what you're saying?
Yep.
Okay, good. Anyone else? What about Seungjae? No. Any idea? Continue. So this we call the avoid the local minima. So here create the planar graph of the network, route in the perimeter until you hit the straight line. So it is unreachable, meaning, oh, I'm not reachable. Then I'm talk to him, hey, this path does not reach, and I don't want to fit into this path, meaning I set the planar straight line, then I'm sending to this guy. So this guy, whenever it forwarding to the next, it prevents go to the lower than this, because if it goes lower than this, it fit into this path. Okay, so set the planar line, planar perimeter, then this packet is not go to this way. So it goes this way and this way and this way. Okay, until you are reachable to the destination. Okay, so how can you do this? Because I have a strong assumption that I know the XY location of my own node. By using geographic routing, I don't need to do RREQ, I don't need to do RREP. I'm just sending to the closest one, and that's it. And I may stuck in the route in local minima. Then I have to prevent it rather than go to the straight right. And I set the planar line and go to steer this way. And these guys are not going to this path because there is a virtual straight line, and drawing virtual straight line is also possible because I know XY coordinate of the all its neighbors. Okay. All right. This is what I prepared today. Any question?
Professor, I have a question on the planar line. How do we know that it has to be above certain level on y-axis? Like, it's like it's not the planar lines isn't really a line between S and T, right? So
Okay.
it's like
Let's
little
say,
above that, right?
yeah.
Well, how do we know that? Yeah.
Okay. So geographic routing is based on coordinate. I know XY location. So let's say it is GPS, latitude, and longitude, right? So whenever I want to talk to S to T, I try to next, and it turns out it's fault. And this guy reversely talked to them. Hey, I try, but I'm not reachable. Meaning, based on the geographic routing, I'm keep trying to the right? Then it's just looping through. There's no mechanism. I tried this way, it doesn't work. So this path, I know my neighbors, right? So I have to prevent this path and this path. Okay. Therefore, I set the virtual line meaning the X is 1 to everybody. Y is higher than 5 and anyone. So if it is lower than, if my next is lower than this guy, they don't go to. Then by setting this Y threshold, they can go to there, first there, and from here, I want to prevent this Y, this threshold. Then I can keep going.
So it tries by going to the Y direction, like to the right.
Y direction, yes, or X direction. It is also possible X and Y and the combination of it. Then this one is AX plus B, simply, right?
Yeah.
N and B. If I put in my location, the next hop is Y, right? This level of computation is feasible, even in the very poor computation device.
Thank you.
Okay, all right. Thank you all. Thank you for the question, David. All right, so if I'm sharing the attendance, so look at the David, 0.7, like overwhelm the others. So participate like what the David is doing, okay? All right, so from next week, next Monday, the courses will be online. Then I can see you face to face. All right, so if you have a difficulty to participate in online, I mean the offline class, the physical class, please let me know earlier, then I can do proper action for you. Okay, thank you guys and have a good day. All right.
Professor?
Yep.
May I have office hour after this class immediately?
Sure.
Okay. I have a question on the assignment. So I understand how to apply the client and server, but I have no idea how to use the library, the address library. So how can I do that?
What do you mean address library?
Wait.
So you mean TCP library, right?
Could you please wait a minute?
Okay. TCP and the socket program. You can use the socket program.
Yeah, I'm using it. And yeah, you